It's the homework help video for Advanced Algebra Lesson 4.3, Matrix Multiplication. First problem we're going to look at is problem 19. Whenever you perform matrix multiplication, the first thing you need to look at is your dimensions. Number 19, the first matrix has dimensions of 1 row and 2 columns. Second matrix has dimensions of 2 rows and 1 column. You look at the innermost dimensions. What I mean by that is what I am putting a little box around. If they are the same, you can perform the matrix multiplication. They are. What you have on the outside, as far as dimensions go, is the size of your answer matrix. One on the left, one on the right as far as dimensions go, so my answer matrix will be a 1 by 1. Now what I actually do to get that 1 by 1 answer matrix is I multiply rows of the first by columns of the second. For instance, in this case, I take row 1 times column 1. What that entails is multiplying 2 times 5, and then adding -1 times 4. So that's 10 plus -4, which is equal to 6. My 1 by 1 answer matrix is 6. After I do my multiplication, row 1, column 1 of the 2 times row 1, column 1 of the 5, I add that to my next product, which is the -1 times the 4. Next problem is number 21. Again, we start by looking at the dimensions. In this first matrix, there are 2 rows, 3 columns. In the second matrix, there are 2 rows and 2 columns. I look at my inner dimensions. They are not the same. What that means is this matrix multiplication is not possible. And if you still don't quite understand why that is, if you look at the multiplication, the 4, this is now row 1 I'm looking at, the first matrix, and column 1 of the second matrix, the 4 would get multiplied by the 1. The -1 multiplied with the 9. This 6 right here has no corresponding number to multiply in the row 1 of matrix number 2. Since there's no number to multiply the 6 by, not possible. Easy way to tell that, look at the dimensions. Third problem we're going to look at is problem number 23. Look at the dimensions again. First one is a 2 by 2 matrix. The second one is 2 rows, 3 columns. Look at the inside dimensions. They're the same. I can perform this matrix multiplication. I look at the outside dimensions, 2 and 3. That tells me my answer matrix will be a 2 by 3 matrix. So now I actually have to go through and do all my multiplying and adding. Row 1 times column 1. So that means 2 times 3 plus -1 times 5. That's my row 1, column 1 answer element. I continue. I still have row 1 times column 2 in the second matrix. That means 2 times -9 plus -1 times 7. That's going to be row 1, column 2. I still have a third column in my second matrix I can multiply row 1 by. That would be 2 times -2 plus -1 times -6. I have now taken this row in matrix 1 and I multiplied it by every column in matrix 2. And now I have to repeat that whole process using row number 2 in the first matrix and multiply that by all 3 columns in the second matrix. So I'll do that right now. So there's the 3 from the row times the 3 from the column in the second matrix. Row times column. Row of 3 and 4 times the column of 3 and 5. I'll repeat that for column 2 and column 3. I still have to perform all the multiplication and the addition to get my 2-row, 3-column answer matrix. And your teacher may want to put all that work that I have in its own matrix. But now it's really either mental math or I type everything in my calculator. Like row 1, column 1, this is really going to be 6 plus -5, which is 1. Row 1, column 2, this is going to be -18 plus -7, which is -25, row 1, column 2. Row 1, column 3, -4 plus 6, for a total of 2. What I have in green now, 1, -25, 2, is row 1 of my answer matrix. I'll continue with row 2. 3 times 3 is 9 plus 20. Row 2, column 1 is 29. Here I have -27 plus 28. Row 2, column 2, 1. And finally, -6 plus -24. Row 2, column 3, -30. Final problem is number 40. It's a story problem involving purchase price and selling price of stocks for 3 companies. Number 40 says, organize the data in 2 matrices and use matrix multiplication to find the total amount she spent for the stock. Well, from the paragraph, from the reading, they tell you exactly how many shares of each type of stock this person bought. So I could take those 3 numbers from the paragraph and create a matrix. She bought 150 shares of utility stock, 100 shares of computer stock, and 200 for food. Utility, computer, and food. Now, if you look at how I wrote the matrix, it's 1 row, 3 columns. So if I'm supposed to perform matrix multiplication, the next matrix that I write has to be 3 by something. So again, my inner dimensions match up. Well, the other piece of information that we need for the total she spent for the stock is the purchase price, which is in the little table to the right of the paragraph. It has to be 3 rows and, say, 1 column. Because from the table it says for utility, she paid $54. Computer, $48. And food, $60. So now every element in my first matrix will match up with its corresponding in the second. In other words, 150 from the utility will match up to 54 from utility in the second matrix. The 100 shares of computer stock will match up the purchase price with $48 in the second matrix. And the 200 for food matches up with the 60 for food in the second matrix. I have my matrices written. I now perform my matrix multiplication. Row times column, 150 shares of utility stock times $54 a share, 100 shares of utility times $48 per share, $200 or 200 shares of food stock, $60 a share. I perform all my multiplication and my addition. I get a 1-by-1 answer matrix of $24,900 that she spent to buy this stock.